Hey everyone, so this lesson you should have your chemistry of water notes out in front of you and just be writing the stuff down as I go along. So we're going to look at the chemistry of water, and I think we can all appreciate the fact that water is a life-supporting molecule, right? So that's what we've got here. Water has life-supporting properties. So we'll get to what those life-supporting properties are in a second, but in order to understand how water does these things, we need to kind of look at water as this molecule, which we've learned about, and we've learned about how the fact that water makes these covalent bonds. So this hydrogen would come in and it would share its electron here, so that electron's being attracted to the oxygen, or that pair of electrons is being attracted to the oxygen, and this pair of electrons is being attracted to the oxygen and creating this bond. And of course, those electrons are also attracted to the hydrogens, and that mutual attraction is what creates a bond. So that's what we've learned. And this is what we call a covalent bond, right? But this bond in particular is a covalent bond, and it's actually more specifically referred to as a polar covalent. So let's look at what that means. So we know it's a covalent bond because it's sharing electrons. What makes it polar? So the attraction of those electrons, remember we said that they're not always attracting them equally. So oxygen wants those electrons a little bit more. So as it pulls those electrons more towards it, the oxygen takes on what we call, well, that was not very good, what we call a slightly negative charge. So we say partial, right? It has a partial negative charge. It's not a full negative charge like the ionic charge. It's just a slight negative, right? Because they're sharing the electrons. And down here, the hydrogens take on a slight positive because the electrons spend more of their time around the oxygen, okay? So what that does, by having a slight negative end and a slight positive end, creates a polar molecule. And just think of the word polar just like we have poles on the planet, poles of a magnet, right? Just polar molecule, which just means opposite ends, right? Oppositely charged ends. Well, what that does, if we start to stick two water molecules together, so side by side, let's say we have something like this. Well, if this end is slightly negative and this end is slightly positive, they're going to have a slight attraction. And I use a dotted line to show that it's a slight attraction. It's not like a covalent bond, which is really strong, right? This attraction here is weak, but it's substantial, it's important. And so if we look down in this picture, we can sort of see these hydrogen bonds shown in between water molecules from one water molecule to the next, right? And these hydrogen bonds are shown with the dotted line to show that they're weak. And it doesn't just occur in water. Over here, there's a molecule in which it's also showing hydrogen bonding, and it's shown by those dotted lines in between. And we'll get to this much later on, but this molecule is DNA, all right, that hereditary molecule. And so a hydrogen bond is a weak attraction, a weak attraction between hydrogen in one molecule and a slightly negative charge on another molecule, on another separate molecule. Now, why is this so important? Well, this gives water these life-supporting properties. Just this little attraction between its molecules creates some properties that are super important and actually lead to water having a very important biological role or life-supporting role, right? That we see here, life-supporting characteristics. So first off, water acts as a good lubricant. So the polarity and hydrogen bonding of water make it a good lubricant. And you can think of it as without water, so imagine like you have all kinds of moving parts in your body. So without water, imagine moving parts in your body like if you put your hands together like a clap and you rub your hands back and forth, just like, you know, when it's wintertime, you're freezing, your hands are cold, you rub them back and forth to warm up. Think about how quickly your hands heat up. You got this sliding friction, right? There's no water in between your hands. Your hands are sweaty, but you can feel the friction and the heat generated. There's a lot of friction. It's not very effective. Putting water in between your hands would be a little bit like putting a pen, right? Put a pen or a pencil between your hands and now rub your hands back and forth, right? Maybe you can hear it, but you've got much less friction. And the polarity of water is what allows that change in friction to occur, less friction. So water is a great lubricant because of its hydrogen bonding. What else? Well, water is a great solvent. So if we don't know, right, what's a solvent? Well, a solvent is a substance that can dissolve other substances. So back to Carly's comment about how salt, you put salt into water and it looks like it disappears. Well, it's not disappearing, it's dissolving, right? This word dissolve. Water is a great solvent. Why? Well, let's look at this salt. Remember that, you know, we have chloride ions that are negative and we have sodium ions that are positive. That's what makes up this salt crystal. And so what water can do is basically due to that polarity where it's got slight positive ends, right? We can see that these slight positive ends attract the negative chloride and surround it. And as they surround it, it's essentially dissolving it. And similarly over here, you can see the slight negative of the oxygen attract the sodium, which is positive, and that sodium here in the middle gets surrounded by water and it's dissolving. So we talk about solutions, right? Solutions are mixtures composed of a solvent and solutes. So what's the solvent? Well, remember the solvent is a substance that can dissolve other substances, right? So you can maybe add that definition over here. I won't rewrite it. Solvent is a substance that can dissolve other substances. So in this case, example, water. Water is a great solvent. What are the solutes, or what is a solute? A solute is the substance that is dissolved. Substance that is dissolved. All right, and so in this case, that would be NaCl, the salt, right? That would be the solute. If you think about a can of pop, well, pop really is mostly water, so water is the solvent, and your solutes would be things like the sugar, maybe the phosphoric acid that's in the can of Coke, maybe it's the carbon dioxide that's dissolved that give the bubbles, maybe it's the caffeine, etc. Like all the particles that are dissolved in that water are the solutes. So water is a great lubricant, water is a great solvent, and all of that is because of its polarity, right? What about the next one? So the next one, water is a great temperature regulator, and we've talked about this in class already, right? When our body heats up, what do? We sweat. Well, why is water such a great temperature regulator? This graph might look confusing, but let's just break it down simply, right? So due to hydrogen bonding, right? Due to, and I'll just abbreviate it with H bonding, right? So due to hydrogen bonding, water has a high heat of evaporation. We talked about this in class, and I could even write the reaction down again, right? Remember we said that energy has to be added to water. So if we have water in a liquid form, so that's an L for liquid, and we want to evaporate it, we have to add energy to turn it into a gas. Well, if you look at this graph here, so here's a graph of the temperature of water at different states. So when it's solid, of course, water has to be, 0 or below. It's frozen, it's ice. Well, it takes a little bit of energy, 80 calories, to turn that solid ice into a liquid. Not that much, because there is very little hydrogen bonding when water is ice. But as a liquid, just like this picture up here, we end up with a lot more hydrogen bonding. That hydrogen bonding has a much bigger effect. And look at what it does in terms of the energy, how many calories, right? Calories is another word for energy. Look at how much energy it takes to turn that liquid into a gas. So when you think of your body heating up, right, water can absorb a lot of that energy as it's converted into a gas and evaporating off your skin. Evaporating off your skin. And that happens, that high amount of energy, that high heat of evaporation is due to hydrogen bonding. If there wasn't that sort of attraction between molecules, it would make it that much more difficult or it would take less energy for the water to evaporate, and therefore water couldn't cool you down as well. Last couple things down at the bottom. So water is a great transport system due to hydrogen bonding, right? Due to water's polarity and hydrogen bonding, it has what we call both adhesive. This means it's attracted to other substances, so adhesive, but water is also cohesive, attracted to itself. And this creates excellent properties like things like surface tension. So here we can see the water bug, right? It can walk on the surface of the water simply due to surface tension. There's enough attraction between, water molecules. Maybe I should use dotted lines, right? These are all different water molecules. There's enough attraction that creates a surface tension, right? So attraction, maybe I'll change it to cohesive. So cohesive properties of water give it surface tension, which if you're this little bug is pretty helpful to supporting its life, right? And secondly, adhesive properties allow for the process of transpiration. So transpiration is the process by which water moves up a tree. So allows transpiration, which is the movement of water from roots up. And again, that is due to adhesive properties. Okay, well, there's a combination here. Transpiration is due to adhesive and cohesive properties. And the best way to see this is if you look at that video right here, and you can see that video if you go on to the course website and you go under chapter 2, the chemistry of life. Sorry, coming up here. So if you look here under our book of videos, you click on that, you'll see both a video on properties of water, which if you want to watch that now would be great. It'll kind of give you some visuals of what I've just talked about. And then this next one, the transpiration, this one that gives you a good detailed look at how cohesive and adhesive properties of water allow water to go from the roots in the ground all the way up to the leaves. That's it. Video number 1. Stay tuned for video number 2. Ooh, how exciting.